question has given us probability of uh, two sets separately and their union, and is asking to find all these probability of composition of two sets. And because the union is given, I'm going to look at the formula for the probability of the union, which is basically probability of the first set plus the probability of the second set minus the probability of their intersection. Now, how's that going to be helpful for us? Because basically the probability of union is given here, and the probability of the first set is given, and probability of the second set is given. I can find the probability of the intersection, and that would be 0.71 plus 0.44 minus 0.92, which is going to be equal to 0.23. Now the next part is asking to find the probability of the intersection of complements. This looks like it's not connected to the rest of them, but with the right formula, it could be connected. So what is the right formula? In this case, I know that the probability of intersection of the complements is by the Morgan law, is the probability of complement of the union. And that is basically 1 minus probability of the union, or 1 minus 0.92 equal to 0.08. Now, the next question is asking to find the probability of E intersect complement of F. So how do I do this? Well, there is another formula that I can use because I already know the probability of E intersect F. And I know that probability of E intersect F and probability of, let me write this down, probability of E intersect F plus probability of E intersect F prime is going to be equal to P of E by the total probability law. I can actually solve for this one while I have the other two values. And this was 0.23, and that other one is 0.71. So the answer is 0.71 minus 0.23. And that is equal to 0.48. Now, if I want to find one of the conditional probabilities, I have all these probabilities over here that I can use to find a conditional probability. For example, if I want to find probability of E given F, I need to find P of E intersect F divided by probability of F, which in this case is equal to, we already computed probability of E intersect F, that's 0.23, and then probability of F is given by the problem, which is 0.44, and so the probability of E given F is approximately equal to 0.523. And you can find more probabilities, but let's go back and look at the second part of this question, which is asking decide whether the events E and F are independent. We have found probability of E intersect F to be 0.23. Probability of E is equal to 0.71. Probability of F is equal to 0.44. And if you multiply probability of E times probability of F, it which this product is 0.3479, which is not equal to the probability of the intersection, which is 0.23. Therefore, events E and F are not independent of each other.